Mr. Harris here, and welcome back to a new video of chapter 9.3. In this video, we're going to talk about applications of neutralization. Just to recall, what's the word equation again, guys? Yeah, acid plus alkali, which we get salt and water. Alright, I'm very familiar with this word equation right now, so let's see some real life, daily life applications. So first of all, I believe all of you will be brushing your teeth every day. Perhaps some of you twice a day, which is very good. So toothpaste, it is actually slightly alkaline. So I know some of you would be using Colgate, Darlie. I'm not sponsoring anyone, but just letting you know. Remember to brush your teeth twice a day. Toothpaste, it neutralizes the acids that is produced by your mouth, by the bacteria. This helps to prevent tooth decay. So make sure you use toothpaste when you brush your teeth. Some other applications are one that I've mentioned in the first video of this chapter. How do you treat stomachache? Some of you might be using some medications, or maybe some of your family members have used some medications that would actually add to the acid that is normally produced in the stomach. So in order to relieve or remove this excess acid, we'll be adding a slightly alkaline medicine, which is an antacid. So this helps to relieve stomachache. So you can let your parents know next time when, or yourself, you may look at the drug prescription. You may read through the manual and see whether the drug is alkaline or an acid. So you will be able to understand more whether it's doing a neutralization for what aspect. Another example is using lime in the soil. This is not the lime you're thinking about. This is not lemon. Oops, I dropped my pen. This is not lemon. This lime is a type of chemical. It's usually calcium oxide, for those of you that are interested to know. So it's alkaline in nature. You add it to the soil so that it neutralizes the acids that are present in the soil. And some of you, hopefully none of you, someone might have been bitten by a wasp. So the wasp sting is alkaline. So what you do is pretty interesting. You add some acid, which in this case, some of you, not I bet all of you have this in your kitchen. You can add vinegar to it. It helps to neutralize the wasp sting. So just add a few drops. Oh, you can let your family know about this. It's very useful. Some of you might have been bitten by an ant. Most commonly, these ants, fire ants or red fire ants, their bites are acidic in nature. So for that, you can add baking soda. So in the market, in Welcome or Parking Shop, you can find sodium bicarbonate or baking soda, which is alkaline in nature. You can add that to an ant bite and it will help to neutralize it. All right, so these are really good tips that I'm giving you, some home hacks, you can say. You're welcome for that. All right, now let's do some questions. When 10 cm cube of dilute hydrochloric acid, so we all know this is an acid, is mixed with 10 cm cube of dilute sodium hydroxide. So by now, without me telling you, you should also know by yourself that this is an alkali. Let's read the options down. Sodium chloride and water are produced. Is it true? The answer is yes, because sodium chloride is a salt, water is water. Option number 2, the resulting solution turns green. Does it turn green? Let's see. Is sodium chloride green in color? We all know sodium chloride is table salt, right? Is table salt green in color? No, it's not. How about water? Is that green in color? Of course not. Water is colorless. So this is wrong. Option 3, the total mass of the solutions increases. Is that true or not? No, it's not. In the previous video, I mentioned about how mass is conserved in neutralization. So in the beginning of the reaction, say for example, if it's 20 grams the total mass, at the end of the reaction, it should also remain 20 grams. So the total mass would remain the same throughout the reaction. So this is wrong as well. So the only correct answer is option 1, which is A. Alright, let's see question 2. Amy measures the change in mass in the neutralization between sulfuric acid, alright, so this is the acid over here, and barium hydroxide. So in this case, this is the alkali. Alright, so let's look at the diagram. So you add the acid and alkali together, and then the total mass is around 137.7 grams. And after the reaction, when the two solutions are mixed, you get a white precipitate formed. So guys, I mentioned earlier what precipitate is. It's some small solids. So in this case, it would be salt. This is an indication that salt is formed. All right, let's read the questions. Which of the following word equations is correct for the reaction? So word equation, acid plus alkali, you get salt plus water, right? Let's have a look. Let me use a different color. Let's see option A. Barium sulfate plus water. This is already wrong, right? Because in the beginning of the reaction, you should have an acid and an alkali, but these two are something else. Let's see option B. Sulfuric acid plus barium hydroxide. Okay, this is the acid and this is the hydroxide. This is the alkali. Seems correct so far. And after the reaction, you get barium sulfate. Okay, that's seems like a salt. We're not sure. And water. Okay, so far this seems okay as well. So I'll just put a tick for now and let's go through the others. I'll come back to that later on, just to verify whether this is correct or not. Let's see option C. Sulfuric acid plus barium hydroxide. So this is the acid and this is the alkali. This seems okay as well. You get barium sulfate plus a salt. So barium sulfate plus a salt. Where's water then? I don't see water. So this option C is wrong as well. Let's see option D. Sulfuric acid plus water. Where's the alkali? I see the acid, but I don't see the alkali. So option D is wrong as well. So from this, we know option B is correct, but let's verify it. So you guys remember how I taught you to identify the salt's name? So first thing is to do is to get, let me rub this out real quick first. First thing you do is you get the first name of the alkali, which in this case is barium, and you check it out whether it's the same. Yes, it's the same. And the second step, what was the second step? You check out the first name of the acid, which in this case is sulfuric, and you put it with the second name of the salt. In this case is sulfate. So from this we can verify that yes, indeed this is the salt of these two acids and alkali. So the correct answer in this case is B. Okay, you can refer to the previous video. I taught you how you could name salts using the same technique that I've used over here. Finally, question 2b, what is the value shown on the electronic balance after the two solutions are mixed? After the two solutions are mixed. So remember, I talked about how mass should be conserved, the conservation of mass. So whatever the mass was in the beginning of the reaction should also remain at the end of the reaction, right? So let's go back and see originally what was the mass. As you can see, originally the mass was 137.7 grams. So let's go back and see which one is the answer. Yes, the answer is B, 137.7 grams. All right, that's it for this video, and that's it for chapter 9.3. In the next video, we're going to talk about chapter 9.4. All right, that's the end of this video. Bye.